So this video is to explain how you fill in the lab workbooks and hand them in. This course has been designed to be paperless. That means you don't need to buy a paper copy of the lab manual from the bookstore. Instead, you're going to be supplied with files that you fill in and hand in. So I'm going to show you how to do this with the first week's lab. So Lab 1 on the Moodle site, and scrolling down here to the bottom, here is the link to the lab manual file. So you open this up, and once the file's open, you do want to enable editing. And by the way, it is a good idea to open this on the lab computer rather than your own device, simply because it'll make it easier to copy and paste screen captures into this file. So right now, I've got this open on our lab computer, and we're going to actually be opening up a program in this folder here later. And I'll take screen captures out of that program and paste them into my lab report here. So you'll want to do that too. So now I'm going to show you some various ways of adding information to this report. So you can click into these areas and type things in, like the name of the lab, or the date, and you also want to add your names. Then below, we see two examples of how we can add more information. So down here, we've got an area where we can just type things, but we've also got these two areas where we're supposed to add a screen capture of something. So the question says that you're supposed to set up the motion sensor and then make a graph of your partner walking away from the motion sensor at a constant fast speed. And then you'll do it again for a constant slow speed. And you're going to screen capture both of those graphs and paste them in here. So the way you do this is you'll click this red button and paste a screen capture over top of it. So now I'm going to show you that. So I'll minimize this. And like I said, this is our lab computer screen. And I'm going to open up this folder here. And I'm going to open the Velocity program, which is the same one that you'll use in your first lab. And once it's open, it looks like this. And what I'm going to do is I'm going to point the sensor at something and then move this something away from it at a constant fast speed. So that'll mimic your partner walking away from the sensor. And I'm going to take a graph of this. So to take the graph, I click Start, and then I start taking my measurement. And now, this graph is what I want to screen capture and put into my report. So to screen capture something on a Windows computer, which is what we have in the labs, you'd hold down Shift, the Windows key, and then S. The screen goes gray, and then I can just click and drag to highlight only my graph. Then I'd go back to my lab report, click on the red box here, and I can paste it in, either by clicking this Paste button or by holding down Control V. And it pastes my screenshot in there. Great. So now I'll do it for the second graph. I'll go back to the program, and this is going to be a graph of constant slow motion. So again, I can click Start and then do constant slow motion. So this would be your partner walking away from the device. And once I have my graph, again, Shift, Windows S, and I highlight just that graph. And then I can go back to my report, click the red box, and paste it in here, either with the Paste button or Control V. And then once I've got that, I can then type in my similarities and differences that I observed between the two graphs. So now let me maximize this, and I'll show you a different way of adding information. So on the next page down, they ask you to make a prediction of what you would see if you had your partner walk left towards the detector at a constant speed. So they want you to make a prediction here. So that's an ideal world case. So it's not going to have any bumps or wiggles or weirdness. It'll just be the theoretical prediction for what you should see for this sort of motion. So you're going to draw in that perfect world case. And down here in blue, it gives you a little tip on how to do that, but I will show you. You click on the graph, and then you're going to insert a line here. So you can go up here to Insert, Shapes, and you click the little down arrow here. And it's going to be these drawing tools here that are the most useful to you. So there's a straight line, there's a curved line, there's a freehand tool. So for example, if I wanted to draw a curved line, I'd click on this one, and then you click, and click again, and double click to finish, and that gives you a curved line. And if you want to adjust things a little, you can grab the corners of this and adjust it around. Now, I don't actually want a curved line here. I want a straight line. So again, click the graph, Insert, down arrow under Shapes, and then I want a straight line here. And that's all you need to do. So that's my prediction for what I think I'll see. And then on the next page down, you would actually do that experiment and paste your screen capture here. And that's what you do for the first part of this experiment, is you would make predictions, then you'd actually do the experiment and paste the graph in, make a comparison between them, and then go and do it again. So you'll do this a few times at the beginning of the lab, and things actually change when you get to question 12. So let me show you that now. So about once a semester, the physics department likes to make you do a hand-drawn graph. So most weeks, you're just going to screen capture your graphs directly off the screen, but in this first experiment, they actually do have you do one hand-drawn graph, and that's in question 12. So instead of screen capturing the graph, you screen capture your data table, and then you're going to graph that and include both the data table and the graph in your report. So question 12 is where you need to capture your data table. So going back to the program, here's a motion that I captured, and I'm going to want to graph by hand the linear part over here. So how do you actually do that? Well, you only need about 10 to 12 data points. And so what you do is you click and drag a rectangle over the linear part, about 10 to 12 data points. And you'll notice that that got highlighted here on the data table. So this is what we want to screen capture, this data table over here, rather than the graph. So to do that, again, Shift Windows S, and I'm going to highlight just the data table this time. And then I go back to my lab report, and again, I can click the red square and then just paste this over top. So now I've got my data all captured here, and this is what I'm going to graph by hand. Now the hand-drawn graph is also going to be included down here. So as I said, you're going to graph your data, and by the way, you will need a slope triangle, and you will need to calculate the slope. But once you've got your graph, it may occur to you that, hey, how am I supposed to get this into the computer now? Well, we have you covered. On your desk, you've got a webcam. So you're going to point this at your graph, take a screen capture of what you see on the screen, and then paste that into your report in the usual way. So let me show you that now. So on Windows computers, like the ones that we have in the lab, there is an app called the Camera app. So you just type camera into this text box here, hit enter, and that opens up this camera app, which shows you what the web camera is seeing right now. So then you grab your web camera, and you get your graph showing on screen. And you don't even need to take a photo. With this camera app, all you're going to do is screenshot it the usual way. So Shift Windows S, the screen will freeze, and then I can just click and drag to select the graph like usual. So like I said, you don't need to actually take a photo of your graph. You could just get it showing on screen and then screen capture it in the usual way. And I don't need my camera app anymore. So I go back to my lab report, click on the red box, and then paste in my graph. Now it's not right side up right now, but we can fix that. If you click on the image, a little handle appears at the top, and you can use that to reorient this. If you want to make it bigger, you also can do that by clicking and dragging the corners. But just make sure that it's nice and visible on there. You will also want to interpret the slope of your graph. So I'll leave that as a question for you and your partners to answer in the lab. But any time that you need to get handwritten work, like this graph or some calculations that you worked out by hand on paper, you would use the webcam and the camera app and then screen capture it the normal way and paste it into your report. Now after you've completed your lab report, so it's all done and you're ready to turn it in to your lab instructor, the next question would be, how would you do that? Well, what I recommend you do is save this file onto the desktop, just so that it's easy to find. So I'll do that now. File, Save As, I'll put it on the desktop, and the default name should be fine. So there it is. Now you're going to want to go back and delete this later, just so that the next group of students that comes into the room can't plagiarize from you. But for now, saving it to the desktop is a good idea, just so that you know where to find it. In fact, I'd recommend that as soon as you open your lab report, you always fill in your names, save it to the desktop, and keep saving it as you work on the lab. So save it to the desktop for now, and then you'll want to submit this completed report to your lab instructor. So going back to the Moodle page here, down here at the very bottom, there's a hand-in link. So I'll click that, and this is where I would hand things in to the lab instructor. So I'd go Add Submission, and I get this drag and drop box here. So let me minimize this a little so that I can see my file. So I'm just going to grab this file, drag and drop it, and now it's ready to be submitted to my lab instructor. So I click Save Changes, and now it's in draft mode, which means I can, if I want to, edit it or remove it, or I can also submit the assignment now to the lab instructor. And like I said, remember to go back and delete your file when you're done, just so that the next group of students in the next lab group can't plagiarize from your group.